Hello, everyone. I'm going to walk through one of my favorite free body diagram problems. Okay, so we are going to take a look at when somebody is jumping up and down. Okay, and so we're going to break this up into 4 sections. When you're crouching, getting ready to jump up, we're going to do a free body diagram for that. When you're actually in the act of jumping up, pushing off the ground, you're in the air, and then when you are landing. Okay. So when you're crouching ready for the jump, and we are going to say my mass is 70 kilograms. And it's a good day, right? Cheat day. So just to make our lives easier, then we know my force of gravity, which is equal to mass times the acceleration due to gravity, which we estimate to be 10 meters per second. Because 9.81, 10, it's a 2% difference, but 100% easier to do math with. So 70 kilograms, 10 meters per second gives us 700 newtons is my force of gravity. Okay, when we're crouching, getting ready to jump, okay, my force of gravity due to the earth, we just said is, what's a G, 700 newtons, okay, because of earth pulling me down. Okay. On the other hand, I'm standing on the ground. I'm not accelerating up or down yet. My body hasn't moved, and so my normal force here is also going to be equal to, let's make that a capital N, is also going to be equal to 700 newtons from the floor. Okay. Now, once you start straightening your legs out, you're pushing against the floor. Okay. My mass has not changed. I have not lost any weight. I have not gained any weight. My mass is still the same. My gravitational force is still 700 newtons. Okay. Earth is still pulling me down. Okay. Now going upwards, be a little bit bigger this time. My normal force, okay, has to be greater than 700 newtons. Okay. Why is that? Well, if I'm pushing up off the ground, jumping up, my acceleration is upwards, which means my unbalanced force must also be going upwards. Okay. And so my normal force minus my gravitational force must be greater than 0. Okay. At the moment, we haven't been given a acceleration or anything else to go off of. We can't say exactly what that force is. We're just saying we know it's bigger because you're accelerating upwards. Okay. Now, once you're in the air, you still have not lost any weight. You have not gained any weight. Force of gravity due to Earth is still 700 newtons. Okay. One might get picky and say, well, you're technically farther from Earth. Congratulations. It's changed like 0.00001%. So nobody cares. 700 newtons still. Hey, mister, what's going up? Well, your velocity is going up, right? Your velocity, initial velocity here, initial velocity is going up. Okay, cool. So what's pushing you up? Think about it. Think about nothing. Nothing is pushing you up anymore. After you left the ground, you're not touching the floor. Nothing's pushing you up. Mister, why am I going up? Well, you're going up because the last time you accelerated, you ended up with a positive velocity here, right? So when you're done here, your velocity was forward. You're going to continue going upwards until something acts on you, unbalanced, and causes you to accelerate back downward. Okay? So then by the time we're done, your velocity ends up going this way, which means our acceleration here is down. Okay, we can actually solve for this. We know our unbalanced force here is equal to gravity because nothing's opposing it. We know that's 700 newtons. Okay. You can solve for using FUMA, right? FU equals MA. Put that up here. Okay. But really, look at that. This looks like the same equation as FG equals mg almost, because it really is. And we will find that my acceleration here is going to be equal to negative 10 meters per second squared. Okay. Technically 9.81, but 10 is close enough for our purposes. Okay. It's negative. Why? Because I consider the downward direction to be negative. Okay. And that's it. You know, I mean, if you're moving sideways, it still doesn't matter because when you're in the air, there's no other forces acting on you other than gravity. A little bit of air resistance, but not enough to notice on you doing a little jump. Okay. And so then again, we're landing here. Okay. I still haven't lost or gained weight. One jump is not enough calories for that to happen. So force of gravity is still equal to 700 newtons due to Earth. Okay. And we again are touching the floor at this point in time. So we've got the normal force from the floor. Okay. Now here's the funny thing. This will also be greater than 700 newtons. Okay. We saw back here that it was greater than 700 newtons. Here again as well. Why is that? Okay. Your initial velocity at this point in time, we're going down, and your final velocity is you're not moving. Okay. And so you've got a negative velocity, we can call it. Okay. If it's down, it's a negative velocity. We end at a zero velocity, which means our acceleration must be positive. So our acceleration is upwards, which means our unbalanced force must also be going up. So we know that my normal force at that point in time is greater than my gravitational force. Now, I want to give you one example here with some numbers in it as well. So let's say when I'm jumping up, okay, well, it's right here. When we're jumping up here, our acceleration is equal to, let's say, 8 meters per second squared. Okay. So now can we figure out our normal force? Yes, we absolutely can. Okay. So our unbalanced force is equal to my mass, which we said was 70 kilograms, times my acceleration, which is 8 meters per second squared. My unbalanced force is, you multiply that together, and you should get 560 newtons. Okay. Put this off the screen, please. There we go. Okay. And so if my unbalanced force is 560 newtons, we know it's going upwards. We know that my unbalanced force here is going to be equal to my normal force minus my gravitational force, okay? And we have two of these numbers, so we can plug in 560 newtons for my unbalanced force. My normal force is what we were looking for. My gravitational force we found earlier to be 700 newtons. You add 700 to both sides, and then we find out that my normal force in this situation would be equal to, let's see, 1,260 newtons. Okay. And so then if we were to redraw this, instead of Fn is greater than 700, we could say our normal force is equal to 1,260 newtons. Okay. So again, all of these problems come down to draw your free body diagram, find your unbalanced forces, find your acceleration, whatever's not given to you, use FUMA to find whatever you're missing, and you will find the answer. Okay, as always, everyone, good luck, have fun, and take it easy.